Okay, this is going to demonstrate how to use or create a 6-point nest to do your alignment inside of Geomagic Control X. This is going to be a 6-point nest on a turbine blade. So the first thing I ended up doing is create 3 planes and 3 vectors that are defined around the origin there. Now, one of the things I've done to make my life a little bit easier is I like to have these features all the time. So what I did was I created a Control X project, saved it in a location, but now every time I go in and say File, New, it's going to open up my base one and bring that data in. So it makes life really easy. Now, how do I make sure it goes back to this file every single time? Under Menu, File, Preferences, there's a setting here called Template CX Project File. And there I have I call it CX base file. And that file there has those features in. So every time I click New, it goes back and actually opens up a copy of that file. So it's a really nice way to carry constructed geometry across without always reconstructing it. So if you have things that you need to build every single time, creating yourself a template file might be the way to go. Okay, so now what I'm going to do is bring in my 2 data sets. So here's my STL and my step model. So I'm going to import that in. And you're going to see the CAD model is going to show up under the reference, and under the measure it's going to be the scan data. Now, I get it in out of date symbol there, which means regen all. So up here at the top, you can see the regen all. That just means, hey, you brought some data in. So these features are kind of out of sync with it. So just hit the update there and it will then clear it out. Now, the first thing I'm going to do is I'm going to put these 2 objects together with a quick best fit, or what we like to call as initial alignment. So under Home, Alignment, there's an initial alignment. And what we're going to do is basically best fit the blue data to its neighbor, which in this case is the CAD model, which is the reference geometry. So we're just going to best fit those 2 together. Now, I keep saying best fit. Be careful, there is a best fit, but that's more of a fine-tuned type best fit. We're going to say initial, click OK. 2 objects are going to get lined together. Now what I'm going to do is I'm going to have to cut 2 sections, or I'm going to cut at least 1 section because I'm going to show you 2 different approaches here. But I'm going to build 2 planes at where these cross sections would normally go. So we're going to go plane, and I'm going to do an offset from one of those base planes that I built. And we're going to say offset. I don't want it to build it on the scan data, and I'm going to put it at 320. So there's my first cross section. I'm going to turn the lock on. So it lets me repeat the command. So we click OK. Now I'm going to come back in, pick this bottom base plane again, but this time put it at 360. Turn off my lock because I'm done. Okay, now it's built the 2 planes where I need it to go. Now I'm going to get rid of some of these things since I don't need to see them anymore right now. I'm going to get rid of all those features and just leave those sitting there. So the first thing I'm going to do is I'm going to cut a cross section at this lower level first, and I'm going to cut a cross section to help me define where my simulated CMM points are going to actually be defined at. So we're going to come up here to Dimensions, 2D, GD&T. We're going to say Add Section, and I'm going to pick this plane here. So you can see it cuts a cross section through the part, and when I click OK, it's going to put me into that cross section. So now what I'm going to do is I'm going to, let's just keep this right now, right? So we're just going to say OK, or exit out of there. Now once I have this guy, what I'm going to do is build 2 points on that cross section to represent where the contact point is. Now if you have the XYZ location of where that tangency point should be on that cross section, then it will save you from having to do this step. But if you don't have it, you got to calculate where it is. So what I'm going to do is I'm going to hide my reference data. I'm going to also hide those planes. Now what I'm going to do is I'm going to come back over to my home ribbon, and I'm going to build a point, and I'm going to pick the solid data. I don't want the dash geometry because that's the measured data or the scan. I want to pick the solid data because that represents a cross section through the CAD model. And what I'm going to do is turn this guy off again, and I'm going to say extreme position. And now the position, I need to tell it a direction. So that's where this is where it's going to go. Because right now it doesn't know what the extreme position is. So I'm going to tell it to look left to right on the part. So by coming down to direction, I'm going to pick one of those vectors that I built. In this case, it's my X. And so now the system is going to look left to right. So now there's two extreme positions here, right? There's the outermost at the contact point here, and then there's the outermost at the contact point on the trailing edge. So what I want to do is a preview and end up building it over here on the leading edge, which is what I really want. So I'm going to turn my lock on, click OK. Now I'm going to do the same thing again, but this time I'm going to do it on the suction side of the blade. So I'm going to come in, and since I'm not sure where it's at on that side, I'm going to pick those two pieces. Actually, let's pick all three. And then for our extreme, let's see, what do we got here? Let me clear these out just so it doesn't, make sure I pick just the CAD geometry. There you go. We don't want it to look at the measured geometry. Again, I'm going stream position, but this time I got to go in the Y direction. So I'm going to turn on my Y axis down there. You can see it sitting there. So for the direction, pick that guy. And again, do our preview whenever possible. So it's putting it on the proper side because it could have came all the way down here near the edge of the trailing edge there because that's the most extreme in the other direction. Looks good. So we're just going to click OK. Now, I could do those 2 points on the other cross section that's located at 360, but I don't want to. I just want to do it in this location here because I kind of want to show you the differences of what ends up happening. So I'm going to bring my CAD model back on, and I'm going to hide the cross section. So those are my contact points that I'm worried about. So I'm going to come in and build my simulated CMM points there. So the first one I'm going to build is going to end up being a rod where it connects into here. So my reference point, this is why we built those points. If I come here and say, let's use that point, I want to use a rod. So we're going to come down here and pick on rod. So you can see the system lays a rod up against that point. And you can see the points of the underlying mesh that falls within the envelope of that rod. So what I want to do is I want to now control the orientation of that rod, and I want to make sure that it's actually measuring in the X direction. So down underneath direction, there's measure direction, and we want to change that from auto to manual, and I want to give it a direction. So in this case, I want to say go with the X. So now that thing's coming directly along the X, and that's going to be important because when we come back to do RPS, we're going to tell that pair how it's supposed to act and how it's supposed to constrain the part. So it could slide up and down and it could slide along the bar, which is fine, but it can only go so far to the left. And that's what we're going to tell it is, hey, this is controlling the X direction. Y and Z, we have no control over it. Now, the other thing that I want to adjust is this angle. It might not have anything or impact our results, but I want to make it so it's flat to what would be considered engine center. So I'm going to say my rod axis is also going to be manual, and the direction of that is going to go along the Y axis. So there we go. So now it's going along the Y. The contact direction is still going into the part, which is what we want. Now the length, that's controlled by this guy. So if I wanted to, I could go in there and just say, give me 25, and it's going to just check within that zone there. Again, how large it is really up to you. If your part had other blades that were in the way, you might want to make sure you shorten that down. So that looks pretty good. So I'm going to put my lock on because I'm going to actually build another one here. So we're going to click OK. Now, if I had done the cross-section approach and built my point, I would also do the one higher up the leading edge, just because all these parameters here are already set for me and it just saves me time. But in this case, since I'm going to try this as a different approach, I'm going to come in and define this point right here just to show you. So we come back to reference position. I'm going to hide my CAD so I don't pick it by mistake. I'm going to pick that point, turn on my CAD so you can see it again. So you can see the rod is using the same orientation as the first position. So we're going to have to come down here, change the manual approach, and tell it we want to measure in the Y axis, and this should be in the X, right? So it looks something like that. Well, the problem is the direction is backwards that it's measuring. You can see it's measuring down here and saying the contact point. So what we need to do is take our double arrow there and flip it So it's on the other side. So now it sees the contact point being right there. Okay. So I'm going to accept that. So that makes it quite easy if you got your points already defined. If you don't, then this is what you're going to have to do. I'm going to turn on my one offset plane, which is up here. And I'm going to kind of eyeball where this thing should go. So I'm going to say reference position and say, I think it's about right there. And hey, I got lucky. It's at 360, which is really where I wanted it to go. It looks like I'm way off, so I'm going to change this and say let's measure it in X, and this should be in Y. And my pick point, that's why it's nice to have data sitting there. It should be somewhere. Gotta be careful you don't pick the plane because it's going to want to set it on the plane. So I'm going to pick about right there. And so you can see my reference position. So I really wanted it at 360. So I'm just going to nudge that down a little bit. So now it's in the spot where I really wanted it. I'm not sure if the X and Y is proper, but I'm going to live with it right now. So we're going to click OK there. And I'm going to do roughly the same thing, which looks like it's going to be somewhere up there. So we're going to change this direction to the measure to be, what was that? Y, axis X, flip the direction. My position, oh, that's pretty close there too. You can see where I picked over here and the tangents over there. So I'm going to accept that. That's just going to give me a big deviation on where the points intersect, but that's fine. Just to show you how, take it the time up front to construct the data to help you will go a long way to then just going in there and picking a point without really realizing where it should go. So there's our 4 rods that we need to define for controlling the positioning of this part. Now the problem is this part can rotate here, right? So if we come in, it can still rotate like this, and it can also move left to right because there's nothing to control it. So it's just sitting on those 4 rods. So this is now going to build the 5th point. So I'm just going to pick a point out here in space. Again, if I knew where I needed this to go, I could type in the reference points. Since I don't know, I'm just going to pick a point and say it's right there. Now, instead of using a rod, typically you have sort of like a pin that's sitting there that it rotates about and then contacts it. Well, you don't want to use the contact or the probe contact because if it gets to the rear end of the part near the trailing edge, it might be thin enough, or if there's enough warp, it might look and see data on both sides of the part. So what we're going to do is we're going to use the disk option. And what disk will allow us to do is project that in. See, those are the points where the contact is going to be at. But it's really going to be just be hitting up here at the top, as you can see with that little vector there, the little green one. That's letting us know where our contact point is. So I'm just going to leave it just like that because, again, this vector is kind of controlling the same as the 2 rods were, right? Oh, it looks like I might not have accepted the last one. Let's just see here. I'm going to click OK there. Come back. Pick about right there. 360 looks good. I think I didn't hit OK on this one. That looks fine. So we're going to hit OK. And then we're going to come back and pick on this point. And just like we did on the other point, we're going to use disk. And I'm going to tell it I want to measure along the Z axis. So we're going to say Z. And again, wrong side. So we're going to flip it over. And that's where this thing's going to hit. Now, part of the things you see here on these guys, I haven't really explained what they are, but that blue zone, that represents the search depth. So if I bump that up to 10, you'll see it gets really large. So that means your part could deform quite a bit. As long as it falls within that range, it will still be able to find and hit the part. We really don't need that much. Some do. And then the size of it is controlled by the search radius. Again, I don't want too large of an area because if there's this lump of mass cast that's sitting there, I could hit that and all of a sudden now my part's going to be off because it's hitting an area that's out too far away. So right there is what I'm looking for. The only thing that I may end up changing, and we can always come back and do it, is I might change that one. Um, Instead of going along the y-axis, I might change it and say normal to the surface. But we'll see what ends up happening here. So we're just going to click OK. We'll turn off our lock. Click OK. So there's our 6 points that we're going to nest the part to. So now what we have to do is go in and create the RPS alignment with it. So I'm going to come in and say RPS alignment, and so I'm going to pick this guy. Now, before I move on to the next one, we all have a tendency to just start clicking them all. I want to tell that point how it's supposed to act. So that's what I'm going to put some constraints on it. So right now I'm going to tell it that the only direction it's supposed to control is X. So I'm going to turn off these guys. I'm going to say minimize those, and you're only supposed to be influenced in the X. I'm going to hold out a tolerance of 0.1. Again, that's just going to determine how much wiggle room it ends up having before it's considered passing or failing. So we're going to go, we got pair 1, so I'm going to come down here to pair 2. And guess what? It's going to control the same direction. And we might not have a lot of data there. We'll see what ends up happening there. Now we're going to go to pair 3, which is this one. I'm going to have to go back to pair 2 for a second, because I think I picked one of my points instead of actually picking the target. So we're going to, in this case, for this guy, we're going to go along minimize in Y, because that's the direction we want to measure in. Yeah, let's go back to 2 and clear that selection. Yeah, see, I picked the point. So I probably need to turn off those points so we can't pick them. And let's repick. Pair 2, let's trash pair 2. There we go. Now we got them all. The order's a little messed up, but that's okay. So this guy here, again, we're going to minimize none there, but we're going to say default minimize in Y. We're going to come over to this guy because it controls the same direction. And then finally on this one, we're going to control Z, but let Y and X float. So that should be all of them. Now it's going to go out and do its iteration. And so there's our constraints. So now if I take this guy, change that to snapped, so we can see you zero those guys out. Okay, and if I turn my measured data back on and then come and do a 3D comparison, there's our results. And again, we can adjust the tolerance band as needed. We'll click OK there. Now, if I wanted to go in and adjust this guy so he's not going along the y-axis, but he's going normal to, what I could do to see what type of impact that would have is I'm going to duplicate this result. So I'm going to rename it first and call it my base. Oh, got a phone call. Base alignment. I'm not going to worry about that right now. We're going to duplicate this. And then we're going to change, what one was that? 4. And so with the 4, with the dist, so instead of manual, we're going to say reference normal. See how that thing changed its orientation? So it was the comparison. It was coming straight out, but now it's going to come in at an angle. So okay there. Now everybody wants to be updated. So now we're coming at a different angle, and let's see what our 3D comparison looks like. All right, so it doesn't look too bad. And then again, we're going to rename this, and we're going to call it 0.4 normal surface. And maybe we should probably rename this a little bit better to 0.4 control constraint Y. Now I want to see how those two look side by side, so we're going to come up here to Tools, And we're going to go to Result Navigator. And so over here on the left, we've got normal to surface, and over on the Y, we got control to the constraint Y. So it looks similar. You can see in the yellow area there, got a little slight change there up here in the blue, because that means it's undersized there. As we come around to the back, you can see in the area where that point is, it's really changed how that gets oriented to the part. So even though it improved it by doing it normal to the surface, so the airfoil shape looks good, especially on the suction side there now. We've now pushed a lot of that down here into the root. Okay, I hope this helps and gives you a better idea of how you can do a 6-point nest within Geomagic Control X.